Hello, Mrs. Runiabates biology students. I'm Mrs. Kiesler. I hope you've been enjoying doing your monohybrid Punnett squares lately. Today you're going to start on an activity called Making a Face. It's a favorite activity of mine and one that students have enjoyed over the years. You're going to go from genotype by flipping chromosomes and looking for the letters that symbolize genotype on them, all the way to phenotype, to the physical features. And in doing so, you're going to create a baby's face. This is going to be your baby. So remember that our genotypes come from our genes, and our genes are found on our chromosomes. And our chromosomes look like this. And when we organize them better, they look like this. This is called a karyotype. This is a karyotype of a biological female. Notice these chromosomes are numbered and that they come in pairs. One comes from your mother, one comes from your father for each. And they're lined up from largest to smallest, as they will be in the activity that we do, until we get to the 23rd pair of chromosomes, which are called our sex chromosomes, where you either have two X's or an X and a Y normally. The two X's are called homologous chromosomes, meaning that they're the same type of chromosome, both X chromosomes. They'll have the same genes on there except maybe different variations. Remember, those different variations are called alleles, such as one of the X chromosomes might have the dominant allele, and the other X that you got from the other parent might have the recessive allele. And then here's a karyotype for a human male. Again, lined up from largest chromosomes all the way to the smallest, pairs 1 through 22, and then the X and the Y here would show a biological male, where the X chromosome comes from the mother, and the Y chromosome, a totally different chromosome, comes from the father. And both of these chromosomes are not homologous. They have different genes on them. The X chromosome probably has hundreds of genes, while the Y chromosome only has about 27 genes. And the main one that we worry about on the Y chromosome are ones that have to do with traits that cause maleness, such as the release of testosterone while you are developing. All right, so having said that, in our activity, it will be a simulation. Your chromosomes will look like this. I've supplied some envelopes that have some that are cut out by past students of mine, and they've already been cut out and folded. So this is what they looked like before they were folded. So the student cut them out, and there's a dotted line in the middle, and then it was folded to symbolize that on one side, like this one has a big G on one side, and the other side has a little g. That symbolizes that the one side came from mom and the other side came from dad. And you're going to flip these chromosomes much like you would flip a coin to see which gene you're actually going to supply to your child. Will you give your child your big G or give them your little g? This is also an example here, chromosome number 5. So if I went back to this picture right here, so that would be this chromosome right there, chromosome number 5. All right, so if you have an envelope with my chromosomes, you'll already have them cut out and folded for you by past students, so you can thank them, say a little thank you that they were already cut out for you and folded. Now, if in your envelope you find that you're missing a chromosome, then I've supplied some pages where you can cut one out quick and then fold it and put it in the packet. So that should make things a little easier. So in most of the envelopes here, you'll open them up and you should find 23 blue ones symbolizing the chromosomes that are going to come from the father. and you should find 23 pink ones, the chromosomes that come from the mother. You'll pair up with someone. It doesn't have to be girl, boy. It can be 2 girls, 2 boys, whatever. As long as there's 2 people, and then decide who's going to take care of the 23 pink chromosomes and who's going to take care of the 23 blue chromosomes. And then you'll also find a directions packet, a booklet that looks like this. All right, here's your booklet. And these, please do not write in them, and please return them to the front when you're done so that they can be used all day. They're kind of big and they take up a lot of paper, so that way we just need a class set. Same thing with your chromosomes in your envelope. Please return those to the front when you're done each day. So your booklet looks like this, so you'll follow your booklet. And with your partner, you can flip all your chromosomes at once and then leave them on that side up for the rest of the game. Or you can flip them as it asks you to do so from the directions booklet. So either way will work, but the first ones you're going to flip are the X and Y. So the pink chromosomes will have an X and an X on both sides, because that's all a female can give is the X chromosomes. But the blue ones will have an X on one side and a Y on the other side. So you'll both flip those, and well, for the pink one, it'll be an X, so that's no surprise. But the blue one will either land X side up or Y side up. And then that will symbolize, if it's an X, then the sperm provided an X chromosome, so it'll be a girl. And if the sperm provides a Y chromosome, it'll be a boy. So that's the very first one you flip. You've been given a data table that looks like, I can't get it to show up here. Let me find it. Got to go all the way to the end of my thing here. So you've been given a data table that looks a little bit like this. I've drawn some lines on it to clear it up a little bit. But this is where you can actually write and keep track of your flips. So from flipping the X and the Y chromosomes, you're either going to circle the X and the X or the X and the Y to symbolize if you had a girl or a boy. Here's where you can write whoever is going to play the role of mother with the pink chromosomes and who's going to play the role of father with the blue chromosomes. And you can even give your baby a name. Yes, that's right. You are flipping chromosomes and creating a baby, going from genotype to phenotype. The genotype are the letters on the chromosomes that you flip, and the genotypes are listed here. These are the results that you get. Now, as you get going, you will be tempted to follow this data table, but please don't do that. Please follow the directions packet, because after a while, you're going to find that you're not going to always flip chromosomes in order. So it will tell you, yes, at first you flip chromosomes number 1 to find the face shape, and then you flip chromosome 2 to find the chin shape, but pretty soon it won't be that way. In fact, you're going to jump from chromosome 3 to 5, and then you're going to get to situations like this, where you have to flip more than one chromosome at a time. Some traits are what you call polygenic, meaning that it's controlled by more than one gene. So skin color in this simulation is controlled by 3 different genes, which are, one of them is on chromosome 1, the other is on chromosome 2, and on chromosome 4. So you're going to have to find, each of you will find those 3 chromosomes and flip them, and then look for the A's and count up how many big A's there were and how many little A's. And then from that, it's kind of a continuum. Let's say that you got 4 big A's and 2 little A's, so it would be this one. Then go back to your data table and circle that correct combination. So I had 4 big A's and 2 little A's. So going back to my data table, there it is. So here it is, says skin color, reminding us it's polygenic. So 4 big A's, here it is, and 2 little A's. My baby's skin would be dark brown, all right? Then I would circle that combination. So again, don't follow the data table. Follow this directions packet. Then you're going to do hair color, which you're going to need 4 different chromosomes for, and you're going to count up the number of big and little H's. Then you're going to do eye color, which is controlled by 2 different genes on chromosomes 11 and 12. And then there's some things that show up that might make you have to rethink what happened here. For instance, red hair is another gene on a different chromosome, and it can actually override others. So if you happen to maybe had gotten, say, blonde hair, but then you go and flip the red hair gene and get a big G, you're going to have heavy red pigment, and that will override the blonde. All right, that's just an example. All right, so keep going through the rest of your packet, and then keep recording it on your data table. You and your partner will have the same information recorded on your data table as you're doing this together. And here's the last one, whether or not your baby will have freckles. This is what the chromosomes looked like before they were cut out. And then comes time for your assignment. When done, make sure your baby has a name and a birthday. That's important. And then return your directions packet and your chromosomes to the front. And then separately move away from your partner for this part. You don't want them to see this. And you're going to draw what your baby looks like at age 15 or 16. All right, so don't draw a baby. Draw a 15 or 16-year-old with all the traits that you circled on your data table. Don't let your partner see it, so that later on you can play a game to see if you can figure out which drawing is your partner's. Hence, that one would be your baby. Can you recognize your baby? All right, and so I just wanted to pull up a couple traits here. As time is going on, some people don't know who Jay Leno is, but that's one of the traits in the activity called Jay Leno chin. A Jay Leno chin is a really long chin. And if you don't know what cleft chin is, it's also known as a butt chin when you have a cleft in the middle of your chin. You may know John Travolta has a cleft chin, or Joey from Friends. There's other fun traits on there like unibrow, right? That makes you look really distinguished. There's a nice looking unibrow. President Bush had kind of a unibrow. All right, widow's peak is another trait. That's when your hair comes to a V in your forehead. Dimples, when your cheeks dimple in, especially when you smile. All right, so those are just a few traits that will show up that you're going to flip for with your chromosomes. All right, hope you enjoy this activity. If you have any questions, ask your teacher, or if you can find me, you can ask me as well.